Now, let's continue with derivatives of the other trigonometric functions. Earlier, we learned the derivatives of sine and cosine. Using those results, we can find the derivatives of the remaining trig functions. One helpful idea is that many trig functions can be rewritten using sine and cosine. Once we rewrite them this way, we can differentiate them using the quotient rule. Example 3. Let's find the derivative of f of x equals tangent x. First, remember that tangent can be written as a ratio of sine and cosine. So we rewrite it as tangent x equals sine x over cosine x. Now the function f of x is a quotient. We can apply the quotient rule. The quotient rule says that we take the derivative of the top function times the bottom function minus the derivative of the bottom function times the top function divided by the bottom function squared. So the derivative of the top function is the derivative of sine x multiplied by the bottom function, which is cosine x, minus derivative of the bottom function, which is the derivative of cosine x, times the top function, which is sine x, divided by the bottom function square, which is cosine square x. Derivative of sine x is cosine x multiplied by cosine x minus the derivative of cosine x is negative sine x multiplied by sine x over cosine square x. So in the numerator, I have cosine square x plus sine square x over cosine square x. Remember the Pythagorean identity? Cosine square x plus sine square x equals 1. So the numerator is 1. The denominator stays as cosine square x. This gives us 1 over cosine square x. And that expression is the same as secant square x. So the derivative of tangent x equals secant square x. This example shows the main idea. We can rewrite a trigonometric function using sine and cosine, and then apply the quotient rule to find its derivative. Using a similar approach, we can also find the derivatives of the other trigonometric functions. The remaining trigonometric functions can be written using sine and cosine, then differentiated using the quotient rule. Now let's summarize the derivatives of the remaining trig functions. The derivative of tangent x is secant square x. The derivative of secant x is secant x times tangent x. The derivative of cotangent x is negative cosecant square x. And the derivative of cosecant x is negative cosecant x times cotangent x. These formulas are important and come up often in calculus, so it's a good idea to memorize them. In the next examples, we'll start using these derivatives to solve more problems. Now, let's look at example 4. Find the derivative of f of x equals cosecant x plus x times tangent x. Notice that this function has two terms added together, so we can differentiate each term separately using the sum rule. We have f prime of x equals the derivative of the first term plus the derivative of the second term. Now, we differentiate each part. First, the derivative of cosecant x is negative cosecant x cotangent x. To differentiate the second term, we have a product of x times tangent x, so we use the product rule. The product rule says we take the derivative of the first times the second plus the derivative of the second times the first. So we take the derivative of x times tangent x plus the derivative of tangent x times x. Derivative of x is 1. So for the first term, I have 1 times tangent x plus the derivative of tangent x is secant square x. So for the second term, I have x times secant square x. So we have negative cosecant x times cotangent x plus tangent x plus x times secant square x. And this is my derivative.